Day 360 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2302, count subarrays with score less than K. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. The score of an array is defined as the product of its sum and its length. For example, the score of the array of integers 1, 2, 3, 4, 5 is 1 plus 2 plus 3 plus 4 plus 5 times 5, which equals 75. Given a positive integer array nums and an integer k, return the number of non-empty subarray of nums whose score is strictly less than k. A subarray is a contiguous sequence of elements within an array. So all right, y'all, that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input nums equals an array of integers 2, 1, 4, 3, 5, and k equals 10. The output is 6. Explanation says the 6 subarrays having a score less than 10 are. So first one is 2. So it's just 2 by itself, right? Because we're doing, it has to be the product of its sum and its length, right? So if the subarray is 2, but it's only one element, that means its sum is 2 and its length is 1, right? Because it's 2, because that's the only element in the array and it's of length 1. So we multiply 2 by 1, which is its sum by its length. Its length is 1 because we're only dealing with one number. Remember, one number or one element counts as a subarray as well. So since it's only one element, we multiply that element by itself, right? So we do 2 times 1, that's going to give us 2. 2 is less than 10. Boom. Then we do the same thing for 1. We do 1 plus 0 would be 1. So the sum is 1. Then we multiply. So we're doing the sum of just the subarray. We're not doing the sum of the whole entire array. That's important to remember. So since the subarray has a count of 1, we're just multiplying 1 times 1, right? The sum is 1 because it's one element, so 1 plus 0 or whatever, however you want to do it, is just 1. The sum is just 1 times 1 because the count of the subarray is 1. So we're doing 1 times 1, that gives us 1. That's less than 10, so that counts as a subarray that has a score of less than 10. Then we come to 4. We do the same thing. 4, the sum of the subarray of 4 is just 4. 4 times 1, because the count is 1, is equal to 4. That's less than 10. So that counts as a subarray that we could count, right? That has the correct score. Then we come down, we do 3. Same thing. 3 by itself. 3 times 1 is 3. That's going to give us 3. So 3 is less than 10. So we can add that. Boom. Then we have 5. Last one, 5. Or not the last subarray, though, but the last element where we just multiply it by, where the sum is itself and we multiply it by 1. So 5, count is 1. 5 times 1 is 5. That's less than 10. Now we're getting into the part where we're going to actually have to add some elements together and get the sum and multiply that by its count. So in this case, we already got all of these elements. We have 5 elements right now. So now, but remember the output is 6, which means there's one more. And this is the last one right here, 2 and 1. When we do 2 plus 1, that's going to give us 3. 3 times the count, which is 2. The count is 2 because it's one element here, one element here in the entire subarray, right? So the count of the subarray is 2. 2 times 3, because this 2 plus this 1 equals 3. 2 times 3 gives us 6, which is less than k, so we can add that to the count as well right here. Then it says, note that subarrays such as 1 and 4 and 4, 3, and 5 are not considered because their scores are 10 and 36 respectively, while we need scores strictly less than 10. So obviously we can't do 4, 3, and 5 because that's going to give us 36. 4 plus 3 is 7, plus 5 is 12. Then we multiply that by 3 because there's 3 elements in the subarray. That gives us 36. Obviously, 36 is way greater than 10, so we can't count that. But this 1 and a 4 might be tricky because that gives us 10. 1 plus 4 gives us 5. Multiplied by the count, which is 2, that gives us 10. But it says we need scores strictly less than 10. So if it's equal to 10, 10 doesn't count. It's close, but no cigar. They have to be less than 10. And then if you go through all of the other elements, all the other subarrays, you'll see it won't work. If we do 4 plus 3, 4 and 3, that give us 7. 7 times 2, 14, too high. We do 3 and 5. 3 plus 5 is 8 times 2, that's 16, too high. You know what I'm saying? So this right here is the only other one that's going to work, because 2 plus 1 will give us 3, and we multiply that by 2, that give us 6. So, and 6 is still less than K. So these are the 6 subarrays that have a score of less than 10 or less than K, and so the output is 6. So remember, we're not returning the subarrays themselves, we're returning how many subarrays are there. In this case, there are 6 subarrays that we can create, so the output is 6, and that's how we got them. I hope that made sense to y'all, but just in case it didn't, let's go ahead and take a look at example 2 just to really make it make sense and bring this home, right? So in example 2, we have the input nums equals an array of integers 1, 1, and 1. This time K equals 5. Output is 5. Explanation says every subarray except 1, 1, and 1 has a score less than 5. 1, 1, 1 has a score of 1 plus 1 plus 1, which equals 3, times 3, which will give us 9, which is greater than 5, so that's not going to work. Thus, there are 5 subarrays having scores less than 5. So if we do 1 times 1, once again, that's 1 subarray. Do it with this one, that gives us 2 subarrays. Do it with this one, that gives us 3 subarrays. Then we do these 2 ones, that gives us a 4th subarray, because 1 plus 1 gives us 2, multiplied by 2, that gives us 4. Then we do these 2 ones, 1 plus 1 gives us 2 times 2, that gives us 4. So now those are our 5 subarrays. Now we can't do all 3 ones like it says right here, because 1 plus 1 plus 1 gives us 3. Multiply that by 3, that gives us 9, and 9 is higher than K, which is why we can't include the subarray of all of the ones. However, we still can get the 5 count of 5 by doing the subarrays that we just went over, that I just explained to y'all. So I hope that makes sense to y'all. It's pretty simple once you understand it, y'all. Just remember, we are adding we're creating the subarray, adding the elements together. Once we add the elements together, we're multiplying that sum by the count of that subarray. And if that count, or if the sum times the count is less than K, then we could count that in our output, right? So that's all we're doing. Hope that makes sense to y'all. And now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all, so let's get started. First thing we need to do is we need to get the number of the elements in the array. So we can say let n equal nums.count, just like that. Now we need to create a variable that's going to store and initialize our answer, or the number of valid subarrays that we found. So we could declare a variable, call it ands, and set that equal to 0 to start. Then we need to create our left pointer, because we're going to be using a sliding window. So we declare a variable called L and set that equal to 0. Then we need to create a variable that's going to store the sum of the elements within the current window. So for that, we are going to declare a variable called sum and set that equal to 0. Boom. Now it's time to iterate through the array with the right pointer. So for that, we're going to say for r n 0 ... less than sign n. We're going to open up the brackets. Now we need to add the current element to the sum. So we're going to say sum plus equals nums square bracket r, just like that. Now we need to shrink the window from the left while the condition is violated. So to do that, we're going to say while sum times, open up the parentheses, r minus l plus 1 is greater than or equal to k, meaning the rule has been violated, then we need to remove the leftmost element from the sum, right? So we're going to shrink the window to see if the rule is still violated after we shrink the window. So we're going to say sum minus equals nums square bracket L, just like that. And then we're going to move the left pointer to the right. So we're going to say L plus equals 1, just like that. Now, after adjusting, all subarrays ending at R and starting between L and R should be valid. So we're going to come right here underneath this while loop, and we're going to say ands plus equals, open up the parentheses, R minus L plus 1. Then all we have to do is return the total number of valid answers. So for that, we could just come right here outside of the for loop, and we could say return ands. Now, that's all the code, y'all. That should be all she wrote. Let's give it a run before we submit it. Make sure it runs properly. But told you the code wasn't going to be that difficult. Look at that. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Oh, 4 millisecond speeds, 28.57% of users. Oh, 1 day. They know my streak longer than this. We day 360. They talking about a 1 day streak. It's all right, though. I'm going to take it. We'll see it. We'll take it. We ain't complaining. But yeah, we'll get those numbers up, y'all, as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us, and I feel like this is a good solution for that. It's easy to understand, it's easy to learn from, and it's a good problem to increase our knowledge on sliding windows. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.